And now I want to go over some example for reference variable reassignments rather than using just a newly created objects. So we got two cases to be covered. All right, so let's now go on to the next one here. Okay, let's now still use the student example over here. We got students, resident student, non-resident students. Okay, and what we have is we got Jim, we got resident students, we got non-resident students, and all these three lines will be valid because you can see this dynamic type here. Can students fulfill the expectation of students? Indeed, because students is the descending class of itself. And similarly, this and this over here will be valid, and this over here will also be valid, right? And before we actually do the variable reassignments, why don't I simply just let me visualize the objects first? Okay, let me do that first. So we got Jim. Let me just do that quickly. We got Jim over here is pointing to some students objects. So dynamically, it would be students. And it's important to note the static type for Jim is students. Dynamic type is, of course, student as well. What about the second objects? Resident students, RS. RS dynamically is pointing to some resident students objects, including premium rates. Let me just emphasize that explicitly. What value the premium rate is doesn't matter for now. So that'll be resident students, and what's its static type? It should be resident students. So let me just put resident students over here. Okay, static type. And finally, let's now visualize this non-resident students NRS. So NRS dynamically pointing to some non-resident students objects. Okay, let me just draw better this one here. Okay, so this one here is non-resident students. Non-resident students. Of course, we definitely have the unique attribute discount rates over here. All right, and what's its static type? Should be non-resident students. All right, so that's about the visualization. And at the moment, let's see what we want to do is we want to check to see whether these two lines will actually be valid, will compile. Okay, we want to see these two. And for variable assignments, the only thing you gotta judge will be their static type. For example, here, can the static type for RS fulfill the static type for Jim? And similarly, can the static type for NRS fulfill the expectation of Jim's static type? That's what we're gonna ask. Okay. And apparently, for the first one here, so what we have is, let's say RS, static type is RS. And also Jim, static type is students over here. Can resident students fulfill the expectation for students? Indeed, because it's a descending class. It's a descending class of the students. So that's okay. So this is okay. And you can definitely argue the same way that this is also valid. I'll leave that to you. All right. And let's say this, after this particular reassignments over here, Jim's dynamic type becomes dynamic type of RS. That's what the slide said. Because you can see here, after executing this reassignments, Jim, rather than pointing to here, is going to point to wherever RS is pointing to. So now they are aliases for the same object. Since they are pointing to the same objects, of course, their dynamic type should be the same, just RS. Okay, so that's really important to highlight. Okay, dynamic type for RS. Okay, which will be RS. And at this point, because of dynamic binding, if you actually try to call Jim.getTuition, in that case, you're basically invoking. Let me just maybe number them. So this is number 1. Okay, and for number 2 over here, if you're trying to invoke getTuition on Jim, so that means you're going to invoke the getTuition on this particular resident student objects, meaning that you're going to apply the premium rates when you actually calculate the tuition. That means meaning that we're gonna call the version of getTuition from the resident students class. Okay, So this will be number 2. Okay. Let's now move on. What about number 3 over here? Number 3 is also valid. So when we execute this reassignments or substitutions, what's going to happen is Jim is now going to point to wherever NRS is pointing to. So rather than pointing to over here, so Jim is going to point to wherever NRS is pointing to over here. So that's number 3. So after number 3, after executing this line, what will be Jim's dynamic type? Jim's dynamic type becomes dynamic type of NRS, right? Wherever, whatever the right hand side for the assignment is. Okay, that's also very important. Dynamic type for NRS. In that case, it will be just NRS over here, because these two, NRS and also Jim, they are aliases for the same objects. Of course, the dynamic type will be the same. Okay, and finally, if I try to invoke the same methods like a Jim.getTuition over here, now I'm really invoking the getTuition on this object specifically, because now Jim is dynamically pointing to a different type of objects. In this case, we're going to apply dr, the discount rate, to calculate the tuition, and that implies that we're calling a different version of the getTuition method that's specific to the dynamic type for Jim. So this will be number 4 over here. All right, you can see this also very pretty much corresponds to what we said about the intuition for dynamic binding, but we're just trying to see that from a different angle. All right, so let me recap very quickly, and then we can move on to the next example. Whether or not the variable assignments should be valid depends on the static type for the both sides. The static type for the right-hand side must be able to fulfill the expectation of the static type for the left-hand side. Number 1. Number 2, when you execute the reassignment at the runtime, you're basically changing the pointer of the variable, maybe from here rather than to here, but to here. Let's say after this particular reassignment. In that case, you're also modifying the dynamic type as I illustrated. And depending on what the dynamic type is, the version of the method that's going to be invoked really depends on the current dynamic type. So it can be either here or it can be here. In which case, we're going to apply either premium rates or discount rate. Right? That's a quick recap. Let me do one more example together with you. What about these lines over here? I can tell you that in this case, we don't even need to visualize, because this line over here is not valid. And also this line here is also not valid. But why? Let's take a look quickly. Okay, you can see here the static type for Jim is students over here, right? So we put Jim here on the right hand side. Okay, let me just do one for you, and then you can do the other one. So the Jim over here, we know the static type is students. Number 1, and number 2, we also got, let's say the first line, RS. RS, what's its static type? It's resident students over here, right? Again, whenever you want to judge whether or not the assignment is actually valid, you only look at the static type. And then this one here, static type will be resident students. So now the question really is, can Jim's static type fulfill the expectations of the static type of RS? So you can see here, RS is resident students over here, right? The static type. Versus for Jim's static type is actually over here, students. So can students fulfill the expectation for resident students? The answer is no. So that's why this will be invalid. Yeah, just get prepared, because later on, once you when you write the written test or the exam, you will be expected to actually write such explanation. It's really important, right? So this will not compile. Simply invalid, meaning that you will fail to compile. And it will be up to you to really try this on the Eclipse to make sure you can see the compilation error. Okay, so that's about the two exercises I'd like to do with you, right? Static type for RS. Let me just highlight it completely. All right, so I think the remaining part of this video will be just to assign some more examples for you to do study. But I think we have covered all the principles already. Let me just go over them quickly. So that's the example I just talked about, right? About valid versus invalid. Okay, that's something you already see. You have already seen. Let's now define polymorphism and dynamic binding, which are the two most important ideas for this inheritance lecture. Polymorphism, an object variable may have multiple possible shapes, right? Remember I said poly means multiple, morphism means shapes. Allowable dynamic type. Basically, once you declare some object variable with some certain static type, all the descending classes of that particular static type can be the dynamic type for that variable because they can fulfill the static type's expectation. That's why. So consequently, so there are each dynamic type, each class that can serve as the dynamic type, or each descending class of the static type. Like a resident students and non-resident student, they are the descending classes of the students. Let's say the student is a static type. Each of the descending classes, they may have their own version of the some method, like a get tuition. In that case, you got multiple versions for you to choose from, but exactly one will be executed. So that will be up to the dynamic binding mechanism. Okay, so that's exactly the example I just talked about. A student's variable, let's say variable was declared as a student's, so they can have different dynamic type. Can be either basically any class that's a descending class of students can be the dynamic type. So it can be students, can be resident students, can be non-resident students, right? Yeah, just watch out exactly how I explain these kind of stuff. I really try to connect what you have learned so far. It's really important. In case I didn't write it down on the notes, you may just want to slow down the video and try to write down the notes yourself. I think that will also be beneficial for your learning. Okay, so this means depending on the dynamic type for the student variable, if the dynamic type happens to be students, in that case, we're going to invoke the get tuition method in the student class, which will only calculate the base amount. Otherwise, for example, if we got resident students as the dynamic type, we'll use the premium rates, use that version that's overridden in the resident students class. And the second concept, dynamic binding, is also it's more like a continuation of what's going to happen at the runtime. When a method is actually called on an object variable, the version of the method executed will just correspond to its current shape, right? So remember, think about how these two ideas are related to each other. Here we are saying that whenever you want to assign some variable, let me just try to maybe give you some summary over here quickly. Okay. Whenever you're trying to do some variable assignments, let's say v1 is assigned to v2. Okay, so v1 has certain static type, and also v2 also has some static type. Let's say static type number 1, static type number 2, right? In order for this to be valid, for this one to be valid or to compile, st2 over here must be a descendant class of st1, which is over here, so that it can fulfill the expectations of st1. Right? That's something we have spoken about many times already. And this part over here is about the variable assignments. This rule over here is really about polymorphism. Polymorphism allowable dynamic types of a particular variable, which we declare as with this, it's a static type. Allowable dynamic types, and it will be all the descendants. Okay, so that's about the polymorphism. Dynamic binding is simply just go one step further. What happened at runtime? At runtime, let's say after this particular variable reassignments, if we say v1 dot some method over here, right? So here, m is simply a method. So each descendants class, each descendant class of st1. Remember, st1 is a static type for v1, which is a declared type. That one will really define the expectation for v1. Each descendant class of st1 may have its own version. For example, either to use premium rates versus discount rate to calculate the tuition. And then I'm running out of space over here, and then I'm going to say continue from here. Which version to call? Which version to invoke depends on the dynamic type. Depends on dynamic type of v1. Okay, depends on dynamic type of v1, like which version to invoke. So this is really about dynamic binding. Okay, and so this part here is really about dynamic binding. Just trying to connect the two concepts together for you. So we really keep trying to sketch, the ideas and put them together. So we got polymorphism, which will determine whether a variable's assignment will actually compile, versus dynamic binding, which determines at the runtime which version of the method is going to be invoked, depending on its dynamic type. All right, let's now go back over here. Okay, dynamic binding. And that's the example we just spoke about get tuition, right? So in this case versus this case, because the dynamic type for Jim goes from resident students to non-resident students. So in this version here, the premium rate will be used. In this case, the discount rate will be used. Okay. And for the rest of this particular video, I'm not gonna do any more examples from scratch, but you can definitely go from slide 50. Okay, we got more examples about polymorphic assignments over here, and also about how the dynamic type can actually change. You should really go over them yourself. Most of the examples have been spoken about already. I'm just repeating them just for reinforcement. Okay, and this is also about get tuition. I think that's the example we did when we talk about the intuition for dynamic binding. You can definitely review them as well. And for the just to remind you about the hierarchy for the smartphone over here, and we got two more examples for the smartphone test. You're encouraged to really build the hierarchy of the smartphone in Eclipse and try to put this console tester into Eclipse to try them out yourself. It's highly recommended. I didn't give the source code to you for a reason. I think you should really try this out. Otherwise, it will be difficult for you to really remember and also understand the concept. And so this example will be very similar to what we did before, but we're now just using the smartphone example. I'll leave that to you to see if you got any doubts. You should reach out to me. Okay, that one we don't need to talk from scratch. And one more over here. Okay, and the first one over here is about polymorphism, just about which variable assignment will be valid. And the second one is an example about dynamic binding to see which version of the method, like a surf web, will be invoked. Okay, so that's about polymorphism and dynamic binding, and now we are done with this topic. And the next one will be another very big topic and tricky one, which is about typecasting.